Welcome to another video on quadratic functions. For this example, identify the vertex and the axis of symmetry given the function f of x, and then determine the minimum or maximum value of the function and where the min or max occurs, and then use the information to graph. Notice that our function is written in vertex form, which in standard notation is a times the quantity x minus h squared plus some constant k. So based on the given function, we have a -1 times the quantity x plus 2, which really is the same as x minus a -2 quantity squared, and then plus the constant 4. So comparing the given equation to the vertex form that's defined in terms of ax, h, and k, notice that the leading coefficient is a -1, which is this number in front of the parentheses. And then our h value is a -2. And then our k value is a constant that's added to the quadratic term, which is the number 4. The vertex is defined as hk, so according to what we have a -2 for h and 4 for k, hence our vertex is -2, 4. The axis of symmetry is a vertical line that passes through the vertex point. And so, in general, the axis of symmetry is defined as x equals the value h. And hence, this becomes x equals -2. Now, because the leading coefficient is negative, this tells us that the graph of the function is a parabola that opens downward. And so let's start with plotting that vertex point. So -2 followed by 4, which is this point. And we know that it's going to open in the downward direction. Now let's go ahead and label in the axis of symmetry. I'll use a green color for that. The axis of symmetry is a vertical line that passes through the vertex point. So we'll indicate that with a dashed line. And now to determine if it's a maximum or minimum value based on the direction of the parabola, this gives us a maximum point. The value is what we want, and therefore maximum value is the y coordinate of the vertex point, which in this case is 4. And where it occurs at, the location is at x equals -2. This is the location where the max occurs. And now to graph this, we simply use additional points to make the parabola look a little nicer. Since the graph of this parabola has the same shape as the graph of x squared due to the value of the absolute value of a. So the absolute value of a in this case is a 1. And so this tells me that the graph of this parabola has the same shape as the graph of the parent function x squared. So from the vertex point, we would go 1 over, 1 down, 2 over, and 4 units down. Normally from the vertex, from the graph of x squared, we go 2 over and 4 up. But this is again opening in the downward direction, hence 2 units from the vertex, we would go 4 units down. And then reflect that half along the axis of symmetry. And now this gives us a pretty good picture of the graph of that function.